Hello. We are going to cover section 4.2 today. 4.2, and we're going to solve systems of equations in 3 variables. For tomorrow's lesson, please print out, there's a worksheet, 4.3a. That's going to be for Thursday, or tomorrow. Then we're going to do part B on Monday, the next time we meet. And then Tuesday, we're actually going to start reviewing. And then Wednesday is going to be test 2. So it's due online by 11:59 p.m. on Wednesday. If we can, we will review both days, Tuesday and Wednesday, and then you would take the test outside of class. Right? So this next section, 4.2, is solving system equations in 3 variables. We'll just go over the geometry, just kind of what it looks like, and then most of our solving today will be by elimination. Okay, so we'll look at what they look like, and then we'll go over elimination. And then sometimes we'll have missing terms. That's okay. And then special systems would be as if we get something like a true statement. Remember, that means infinitely many solutions. Infinitely many solutions. And then a false statement, like in our other problems, would mean no solution. Okay, so let's just look at the geometry of it. Our answer is going to be an ordered triple. So that just means x, y, z. We'll have 3 variables now. So if you look at these pictures, most of your problems, because we have 3 variables, we're going to be in 3 dimensions. So most of your problems will be one solution point. And that solution point would be x, y, z. X, y, z. Every once in a while we'll get infinitely many solutions. That could look like either of these scenarios. So if we're talking about 3 dimensions, we actually have 3 planes. And those 3 planes could intersect at a line. And the reason why that's called infinitely many solutions is because any point on that line could be a solution. Or maybe all 3 planes here in letter C are right on top of each other. So that would also be infinitely many solutions. And then the ones down here would be no solution. So all 3 planes do not intersect at once. So if there's an example for letter D, they're all parallel planes. Or letter E, 1 and plane 3 intersect, 2 and plane 3 intersect, but 1 and 2 never intersect. And then you see the other 2 examples as well. You don't have to know the visuals, but sometimes it is nice for students to see that. Okay, now they give some more examples. You can read that over on your own. In the book, it talks more about the geometry. Now we're going to actually use algebra, and we're going to solve a system of 3 equations of 3 variables by using elimination. Now the book has several steps. It actually has 6 steps, and you can find this on page 227. I actually like just to go through the problems, and then I'll give the directions as we go. Okay, now I did create an extra example that was not in the book. I thought this might be a little bit more helpful when we're solving systems. I like to call my equations A, B, and C, so when I refer to them, it's a little bit easier. Our first goal is to get 2 equations with the same 2 variables. The same 2 variables. Or the book will describe it to eliminate the same variable in 2 different equations. Okay, so what I really want to look at is look at my x's, then I look at my y's, and then I look at my z's. And are any of the variables opposites in any of the equations? Well, if you look at equations A and C, you see that the z's are opposites. So let's start with that. That looks easy enough to me. So I'm going to copy down equation A, and I'm going to copy down equation C. Now, as you're doing these problems, each problem does take up a lot of space. So leave enough room. Some problems may take up a whole page. Okay, leave enough room for that. Also be very careful as you're copying down the problem that you don't make any mistakes, because one little mistake will throw your whole problem off. Okay, now when we're solving by elimination, you remember from the last lesson, if we add straight down, something's going to get eliminated, and the z's get eliminated. My 3x plus x will give you 4x. 2y plus 4y gives you 6y is equal to 28. Now I got a new equation, so I'm going to call that letter D. Any new equations go with the next letter. Okay, now look at what I have. I have an equation D that has two variables, x and y. So what essentially I want to get over here is another equation E that's also in terms of x and y. So if you look at my first goal, get two equations with the same two variables. So I want two equations with x and y. Or eliminate the same variable in two equations. So I want to eliminate z again, but I have to do a different combination. So look back, instead of A and C, what combination could I get? Well, I'm going to look at B and C. If I look in B and C, I'm just going to write them down. Sometimes it helps just to see them next to each other. So I have in B, I have 2x minus 3y plus 2z is equal to negative 16. And C, I have x plus 4y minus z is equal to 20. Now if I compare my z's, over here I eliminated my z's, so I want to eliminate the same variable. How am I going to do that? Well, if I multiply equation C by 2, then I can get my z's to be opposite. So I'm going to multiply equation C by 2. And I'm kind of running out of room, so I'm going to have to kind of do this in my head. Now some people do this over here and they just distribute. That might be helpful if you do that. My equation B, I'm not going to do anything with, so I'm going to just recopy. 2x minus 3y plus 2z is equal to negative 16. Whew, I made it. When I multiply equation C by 2, I get 2x. 2 times positive 4y is positive 8y. 2 times a is z is minus 2z is equal to 2 times 20 is 40. Now I can add these straight down. 2x plus 2x is 4x. Negative 3y plus 8y is 5y. And look at my z's, got eliminated. Is equal to 24. So I'm going to call this equation E. And thus I got my first goal, is to get two equations with the same variable, x's and y's. Perfect, I got that done. Now what I usually want to do is line those guys up. And sometimes it's helpful to kind of draw arrows so you know you're going from where to where. So I will line up D and E, and I'm going to rewrite them. Okay, so now what I want to do is I want to eliminate another variable. So combine two equations with the same two variables, and now I want to eliminate either x or y. Well, if I look at the x's, if I subtract, I can eliminate my x's. But some people have a hard time with subtracting. So what they'll do instead is they'll multiply -1 times e. And if you do -1 times e, then